Hello and welcome to another video. In this video we're going to be working on last moment before all ants fall out of a plank. So you have a wooden plank of length n units and you have ants walking off the plank, and each ant moves at a speed of 1 unit. Some ants move left, some ants move right. When two ants and moving at different directions meet at a point, they change their directions and continue moving again. Assume changing directions does not take any time, and when an ant reaches the end of the plank, it falls off. So given an integer n and two rays left and right, the positions of the ants moving left and right return the moment when the last ant falls off the plank. So honestly, this first example is kind of hard to follow. So we're actually just going to make our own examples, and then we are going to kind of like see if we can get the pattern. So I have this like timeline here, and we're going to use this, and maybe let's make a few copies of it, just in case we need it to show a few different times. So we're going to have some times here. We have like 4 copies or something. Okay, there we go. So we'll start with 2 ants. So obviously, we're not going to go through the example of all ants going in one direction, but it's pretty straightforward, right? If all ants go in one direction, it's just the length of like however long it takes for the last ant to get to the end. Also notice they ask you really what's the time that the last ant is actually like ready to go off the end of a plank. So if you just had 1 here, this would be 4. It wouldn't be 5, because it would be here, and then like they said at like 4.01 or something, it would be off the plank. So you want to return 4. So let's just take 2 ants that are walking toward each other and see if we can notice anything. So let's just have these 2, and we'll have time equals 0 here, time equals 1, time equals 2, time equals 3. That should be enough. So at time equals 1, they basically move up over here. Time equals 2 over here, or sorry, time equals 1 over here. Time equals 2, they actually hit each other and go the other way. So this ant would turn around, and then this ant would also turn around. So this, let's call this ant A, ant B. So ant A would turn around and go this way, and ant B would turn around and go this way. And from here, it's going to take another 2 seconds for both of them to get to the end. So it would take 4 seconds. So this one's kind of hard to see a pattern, but let's try to actually have these ants start at a different location. But notice that these ants, like the farthest ant is 4 away from the end, and they took 4 here. So let's actually, let's try to have them start at another location and see if we can notice a pattern. So let's say an ant starts here, and an ant starts over here. Oh, we do have to make sure that they intersect. So let's actually start here. There we go. Okay. So now let's see what happens. We'll call this ant A, ant B. So notice that right now, ant B would take 4 seconds to get to the end, and ant A would take 2 seconds, right? And so 1 second in, if there was no other ant, this one would take another second, and this one would take another 3. But once they collide, A turns around, so A goes this way, and then B goes this way. So notice that now, B would have taken another 3 seconds, but now it takes 1. So basically what happens is whenever 2 ants collide, the time they would have taken swaps, right? So here, B would have taken 3 seconds, like after 1 second, it takes 4 total. If there was no intersection, and A would have taken 2. But now that they collide, basically it's kind of the same, it's almost the same thing as imagine they just like pass each other. It's basically the same thing. Like if they pass each other, it would be the exact same situation, except now like 1 ant would get there later, but the total time for them would be the exact same thing, right? If B just went all the way across, it would take 4 seconds, and if A went all the way across. So now A would take 3 seconds and B would take 1, so they basically swapped the times. So ants colliding is basically the same thing as the time. It's basically the same thing as them pass each other. And so we can use that, right? So we notice that like it's basically the same thing. So now let's add 1 more ant maybe, and let's kind of see what happens. So let's have an ant over here, an ant over here, and then maybe like an ant over here or something, or over here. Okay. So let's see what happens. So notice this ant A, ant B, ant C. So ant A would take 3 seconds to get to the end, ant B would take 2 seconds, and ant C would take 4 seconds, right? So let's see what happens when they move towards each other. So after the first second, A will be over here, and it needs to move 2 more seconds to get to the end. And B and C collide, so C turns around and now takes 1 second, and B would take 3 seconds. So notice they swapped again, right? So B got the value of C and C got the value of B. So they basically swapped. And so now let's see what happens. So after 2 seconds, C is going to be on the edge here. So C is pretty much done. We don't even have to draw it. And A and B will walk past each other. So A will go over here, and B will go over here. So then A needs 1 more second, and B needs 2 more seconds. And so now they'll just keep going until they get to the end. So the answer here would be 4 again. So notice no matter how many ants, you can keep trying this with more ants. No matter how many ants you draw, the time, all you're doing in a collision, you're just swapping the times for 2 ants. So if one ant would take 2 and the other one would take 5, you're basically swapping that. And so if in every collision you're just swapping values, that means that, you know, whatever ant would take the longest, anytime it hits a collision, would just swap with another ant. So that ant would now take the longest. And so it doesn't really matter like how many ants you have. Essentially, all you need to know is one ant would take the longest, and it either doesn't collide with anything, in which case that's your answer, or every time it collides, it passes its time onto some other ant. And then when that ant collides, it passes its time to some other ant. And when that ant collides, right, you're just doing like a swap. So that's the easiest way to think about it is every time you have a collision, you just swap the times. So no matter what, the ant that takes the longest is going to swap its time to something else. And so that one ant would take the longest. So really what we're trying to basically figure out is, it's a pretty easy problem. Just if there are no collisions, what's the ant that takes the longest? And that one's pretty straightforward, right? We have an array of ants going left, and we have an array of ants going right. So for ants going left, we just take, like, let's say, or sorry, for ants going right, let's say we have an array of like 0, 1, 2, and whatever. So we'll just take the smallest value in ants going right. And then how long does that take? Well, it's just going to be n minus that value, right? So let's say we have 0. So for ants going right, the ant that's going to take the longest there is going to be n minus whatever this value is. So n minus, let's call that like ri, the smallest one, right? So we'll just take the smallest one there. And similarly, for ants going left, we'll have some values. Let's say we have like 3 and 4 or whatever. The ant that's going to take the longest is the one that's farthest to the right. And how long is it going to take? It's just going to take whatever value it has. So an ant at 3 would take 3, and an ant at 4 would take 4. So you just take the max, like the one that takes the longest going right, and the one that takes the longest going left, and you figure out which one takes longer there. And that's basically your answer. So that's going to be the ant that takes the longest to get to the very end. And that's pretty much all there is to do with this problem. Once you recognize that in a collision, ants just swap times. So you're not like saving any time, but basically some ant would still take the same amount of time as the longest would have taken. It's just going to like swap a bunch of times with a bunch of other ones, right? You can almost think of like every ant has like an envelope, and one envelope has like something bad in it. And essentially every collision you just swap envelopes. There's still going to be that like bad thing in there that is still going to remain. It doesn't change. So that's basically all you need to solve this problem, is recognize in a collision, you're not actually saving time or making time longer. It's basically the same thing as just, you know, them going the same way, but you just swap the times, right? So if one starts almost at the end and it has to turn around, it has to go all the way back. And then if one has to go really far and it turns around, it barely goes back. So that's pretty much all you need for this problem. And now we can code it up. So we can just actually do a one-liner here. So we can just say return the max. So we're going to get the right side and the left side. So for the right side, we're going to say n minus min right, because the values going right are going to be like, the one that's going to take the longest to go right is the smallest value because it has to go the farthest. So we're going to say min right if right, but right might be empty. So we'll say if right is empty, then we'll just do n, because n minus n is 0, so then we'll just take the other value. So we could do that. And then for the left, we'll kind of do the same thing. So we'll say max left, if left, else 0, right? Because one of these arrays can be empty. And that's pretty much all we need. So we literally just say, look at the two arrays, look at the ant that takes the longest, and that's our answer. Because all you're doing is swapping times. You're never reducing that time for the longest ant to get to the end. And let's take a look. And there we go. And yeah, that's literally all for this problem. So once you recognize it, Not the best problem, honestly, because it's kind of like once you recognize the trick, it's really easy. It's just like, can you recognize the trick? And you can kind of see it in the picture. Like, right? It's the same kind of thing where, like, if you just do enough of these, you just notice that, like, the ant that needed to take the longest, that's always going to be that time. And anytime you have a collision, all you're really doing is you're just swapping times between your two, swapping times left over between your two ants, but you're not, like, saving time or anything. So yeah, obviously this is going to be an, we can do the time really quick. It's going to be an O of n. So, well, it's actually technically going to be, I guess it's like O of 2n or something, right? I don't know how many numbers. I think it's like left can have, I think left can have like, let's see, n or something. Yeah, so left is basically length n, and right is basically length n. So this is just an O of n solution. We're just going through both. And for space, it's going to be O of 1 because we're just getting the max of the max. And yeah, I don't think they're sorted to begin with, so I don't think you can just, if they are sorted, I don't think they are, then you can just get the min value and the max value, but they're not, I believe they're not guaranteed to be sorted. But yeah, if they are guaranteed to be sorted, you can always take the leftmost left value and the rightmost right value, and that would be an O of 1 solution. I mean, yeah, but I don't think they are sorted, so yeah, I think you have to actually still get the max because it doesn't say it in here. So yeah, that's gonna be all for this one. So hopefully you like this one. Kind of a weird problem, but yeah, essentially just draw it out, draw out a bunch of examples, write down the times, and notice that all you're doing is swapping times. You're not saving any time, and then you kind of get it. And so that's gonna be all for this one though. And if you liked it, please like it, and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.